So, how are you all? Meanwhile, let me see your chats. Okay. So, please do respond. All right. So, as you know that we had started the foundation course for the electrical machine quite a week back, and we have completed almost 4th lecture. Basically, the 4th lecture was the part 1, and this is going to be the part 2. Okay, so in the part 1 we had discussed quite important thing related to the laws of the rules of the electromagnetism, that is Fleming right hand left hand rule, Fleming right hand palm rule, and we have seen quite example which are going to be very helpful for your electrical machine. Okay, so first of all, please confirm audio video whether both are clear or not. Okay, so guys, one request, please do like the session button which is given over there. So please do like this session, and also please share the session with your friends so that they can join as quickly as possible, and we will definitely going to see a quite of challenging competitive environment, to be precise, among us. So please ask the your fellow members to join as quickly as possible, and also please to subscribe our YouTube channel. It is very important because we are coming up with a new more initiative which is definitely going to help student in their you can say the preparation journey. All right, so for that you should first subscribe our YouTube channel, and also do not forget to press the bell icon. All right, so those who are willing to join our Telegram group, the link is already given in the description box, so please do hit that link, and after that you can be easily able to join our Telegram group, because there we are sharing a lot of MCQs, the PDF of the session that we are conducting right now. The PDF of the same is going to be uploaded in the Telegram group, the peer Telegram group of the IMS. Okay, so shall we start? And please confirm audio video both. Shall we start? Okay. So this is going to be the part 2, rules and laws of the electromagnetism. Part 1 we had already discussed on a last week, that is on Wednesday, and those who have not watched all the lectures, or even like any lectures of electrical machine from the foundation course, once this session is going to be over, please do watch all those sessions, because definitely it will going to boost up your electrical machine subject. Okay, the concept basically. All right, so let us start with the lecture number 4, part 2, rules and laws of the electromagnetism. So whatever doubt you are having, please feel free to ask over the chat box. Definitely I will going to answer all of your queries, so do not get worry of that. Whatever doubt you are having, a general doubt related to the technique, means related to the particular session, so you can ask me, then definitely I will going to try to I will try to answer all the queries at per my best level. Okay, so let us start with the first law, that is Faraday's laws. So one cannot imagine the electrical machine without this law, Faraday's law. It is a very, very important law in the electrical machine. Whatever thing the machine has been designed, all those things is basically what, hovering around this law. So Faraday was a scientist who introduced, basically not introduced, who invented, you can say, this particular law. And what are those law? What is the statement of the Faraday's laws? See, Faraday's laws states that the magnitude of the induced electromotive force, that is EMF, in a circuit is proportional to the rate of change of magnetic flux linkage through the circuit. Okay? So what do you mean by Faraday's laws? If there is a change in a magnetic flux linkage, then EMF is going to be induced in the particular circuit. Okay? So in a simple manner, let me explain you. First, let me discuss about flux. What is flux? Okay, so flux is what? A process of flow. It is a process of flowing. See, like suppose if in a pipe, if water is flowing, we can also say that the water is fluxing. It means that water is flowing through the pipe. So it is a definition, a simple definition you can find in your dictionary. So this is flux. Now what do you mean by magnetic flux? What do you mean by magnetic flux? Very simple. A flow of magnetic lines is nothing but your magnetic flux. A flow of magnetic field lines is nothing but your magnetic flux, and this is represented by, just a second, represented as phi. This is represented as phi, and its unit is in Weber. Okay, its unit is Weber. Got the idea? Any doubt in this? So what I have did, I am here I have break the words into a separate term. Okay, and we will going to combine all the definition at last. Now come to the magnetic flux linkage. Magnetic flux okay, what is the definition? What is the definition of the magnetic flux linkage? See, a flow of magnetic flux, it is linking to something, na? So that is nothing but the magnetic flux linkage. But where it is linking? It is linking to the number of turns of a particular coil. Let me take an example. Suppose you have a coil like this, which is a n number of turns. Let me take here, you are having capital N, n number of turns. Then the flux passing through it, or the flux is in contact with this particular turns of a coil, is nothing but flux linking to a coil, is magnetic flux linkage. Got the point? So its definition is the total amount of flux, the total amount of flux passing through n number of turns of a coil is nothing but your flux linkage. Am I clear? Am I clear? So see, suppose see, as I told you, this is what magnetic flux which is passing through the coil. So let me take a total number of flux which is passing. Let me take a general example. Sorry. Let me take a general example here. Suppose a total flux phi, it is passing 2. A 2 is passing here, and your n, let me take the total number of turns as 3. Then magnetic flux linkage, which is denoted by psi, then psi will be equal to what? Then psi will be equal to what? N into phi. N into phi. Now this is equal to 6. this is equal to 6. Basically Weber, it is a Weber, because N, which is a turn, which is not having any unit you are having for the phi. So it means that 6 Weber is what linking, or basically not 6 Weber, a flux linkage value is here what? 6. So from here I can conclude that if phi is more, or if N is more, if phi is more or N is more, then your flux linkage is going to be more. So please remember this formula. Meanwhile, let me note down here N into phi. So this formula is very, very important. Okay? Now what Faraday told us, that the magnitude of the induced electromotive force EMF in a circuit is proportional to the rate of change of magnetic flux linkage through the circuit. So this is what magnetic flux. Now if it is changing with respect to time, then it is then it will going to have the EMF. So what do you mean by this? Okay, just a second. Okay, so when a flux is a sinusoidal in nature, then an EMF will induce, then an EMF will induced in a coil. Okay. So what do you mean by this? Let phi equal to phi m sin omega t, phi m sin omega t. Now as per the definition of the, or the statement of the Faraday's laws, what it tells? It tells that E equal to N d phi by dt, or better to write E equal to d psi by dt. Okay. Now if you look at the psi value, or the expression, not the value, so it is N into phi. So N is what? Number of turns, which is constant. So with respect to time, N is not going to change. So we can take it out from the derivative. So N into d by dt of phi. D by dt of phi. Now if you see this formula very carefully, you come to know that if phi is constant, then E becomes 0. Am I clear? If phi is constant, then E becomes 0. It means that no EMF is going to induce. So for what value of phi, or for what nature of phi, the EMF is going to be 0? As I told you, it has to be constant. Then if a current or if a flux is constant or fixed, then no EMF is going to be induced. This is the reason why in a transformer you are having the alternating current, because current is responsible for the flow of magnetic field. ठीक है? तो इसीलिए करंट को क्या लेते हैं हम लोग? ऑल्टरनेटिंग. वी आर नॉट गोइंग टू टेक द डीसी करंट, बिकॉज फॉर द डीसी करंट the magnetic flux is also going to be constant and it will going to give you EMF as 0. Therefore transformer will not going to work. So let me write a point here. Note, for a DC flux, EMF becomes 0 Therefore, transformer will not going to work, hence flux should be sinusoidal or co-sinusoidal, both are same, or co-sinusoidal in nature. This line is very, very important, and this formula is very, very important. Am I clear? Any doubt in this, my dear friend? Any doubt in this? ठीक है? So this is all about theory portion of the Faraday's law. But to induce an EMF, what elements are required? To induce the EMF, what elements are required? See, the very common point is that EMF is inducing, and we know that EMF is going to be induced whenever you are going to have a current, and therefore a current is flow in the conductor. So we require a conductor, है ना? एक conductor चाहिए होगा. Second, we require a magnetic flux. Phi कहाँ से मिलेगा? From the magnetic flux. And a variation between d phi by dt लिखा हुआ है ना, a variation in the magnetic flux. तो वो कैसे होगा? जल्दी से बताएं, वो कैसे होगा? देखो कैसे होगा? See, what are the requirement? First, the first requirement is set of conductor in which the EMF is going to induce. Set of conductor. Second, anybody? Magnetic field. Magnetic field. Third one, relative variation. d phi by dt लिखा था ना, relative variation. So this relative variation between the conductor and magnetic field, this can be generated in two manner. What are that? The first one, the first variation is known as time variation. What do you mean by this? Here the conductor is fixed, it is not moving, whereas magnetic field is moving. Means the magnetic field is basically what? Sinusoidal in nature, and the conductor is fixed, it is not moving. It means that such kind of EMF are induced in transformer and is known as statically induced EMF, because here conductor is stationary as it is not moving. So this is used in transformer. And the EMF that is induced is known as statically induced EMF. Statically induced EMF, because here conductor is stationary. And the second one, that is space variation. Space variation. So what do you mean by this? Here the magnetic flux is basically a constant, it is not changing with respect to time, but at the same time your conductor is moving, है ना? See, let me take an example. See, we have a two body here. Now I want a relative variation or a relative motion between these two. तो वो कैसे होगा? या तो ये पेन is going to move, then you are going to have the relative variation, or else this bottle is going to move, then also you are going to have a relative variation. In the same manner, in the first, magnetic field or magnetic flux is varying, and in the second part in the second part your conductor is moving. Therefore, such kind of EMF is known as dynamically induced EMF or motional EMF or rotational EMF, some may used to call. ठीक है, और ये कहाँ पे इंड्यूस होगा? These are going to induce in your induction machine, DC machine and synchronous machine. In this you are going to have the such kind of space variation. And what EMF is going to induce? Dynamically induced EMF. Dynamically induced EMF or motional EMF or rotational EMF. ठीक है, so this is what the requirement. But is there any drawback of the Faraday's law? Yes, we have a drawback. And what are those? The drawback is it will tell you about the magnitude only. It will tell you about the magnitude only. But what about polarity? ठीक है, let me take an example. Suppose this is a coil and EMF of E, let me take 5 volt is inducing in this particular coil. So 5 volt E is inducing in a coil. Let me take this point as A and this point as B. So which is positive, A or B? Which is positive, A or B? We cannot able to tell because your Faraday's laws will give you only magnitude, not the polarity. Am I clear? Therefore, this is a drawback or a limitation, you can say. It cannot able to determine the direction for the induced current, because from the induced current your EMF is going to be generated. Direction or polarity of the induced current for direction and EMF for the polarity. ठीक है? Now my dear friend, how we can find its polarity? It means, sir, this Faraday's law is not complete. Yes, you are true. You are correct that the Faraday's law is not complete. Then how is going to be completed? When Lenz's law will come. So Lenz's law comes here and it makes the Faraday's laws complete. And what is Lenz's law? I know all of you are knowing, but let us read this statement. Lenz's law states that the direction of the induced EMF in a conductor or a circuit is such that it opposes the change in the magnetic flux that produced is. ठीक है? That produces or produced it. In other words, when a magnetic field is changing, the induced current flows in such a direction as to produce a magnetic field that opposes the change in the original magnetic field. So what do you mean by this? Ajay, hello Ajay, voice बहुत low है. नहीं, chat option होगा. Chat आप तभी कर पाओगे when you have subscribed to our YouTube channel. एक बार चेक करें क्या आपने उसी Gmail ID से लॉगिन किया हुआ है जिससे आपने सब्सक्राइब किया है. और वॉइस लो है तो एक बार मैं चेक कर लेता हूं. अजय, प्लीज वेट. Ajay, please check. Now it is fixed. The voice is fixed. Ajay, please confirm whether the voice is now fixed or not. Sir, flux linkage क्या होता है? As I already told Ajay that linking of a magnetic flux through a coil is known as magnetic flux, or the amount of flux or number of flux passing through a n turns of a coil is your magnetic flux. ठीक है, चलो. So come to the Lange law, as I discussed a quite minute before. Clear, sir? Okay. So as I told you that Faraday's laws is having a limitation, and what is that? It only tells you about the magnitude, but it can't be able to tell you about the polarity. Okay. So how we can find its polarity? By using the Lange law, and what it tells that effect opposes the cause. Effect opposes the cause. So let us understand this Lange law and Faraday's law together by the help of one example. ठीक है, चल. Let me take example 1. अजय सर, फ्लक्स लिंकेज मैक्सिमम होने पर ईएमएफ मैक्सिमम होगा या मिनिमम? फ्लक्स लिंकेज मैक्सिमम होने पर ईएमएफ विल बिकम जीरो बिकॉज डेरिवेटिव बिकम्स जीरो. ठीक है. Okay, just a second. ये क्यों नहीं बन रहा है? ओके, ठीक है. Okay, assume that you are having one iron frame. In that iron frame, you are having the n turns which are wrapped around this iron frame. Now please listen the lecture very carefully. It is very important to understand, if you understand this law very carefully, then you can understand by default the transformer, because the transformer working principle depend on the Faraday's laws and Lange law. Okay. So this is an iron and a copper wire is wrapped around this iron frame. Now I want that the EMF which are inducing, let me change the color, the EMF which are inducing at A and B, what will be its polarity? Whatever EMF is inducing over here, I want to find its polarity. Okay. But for that, what I require magnetic field. So let me draw the magnetic flux here, just a second. So this is phi external. This is phi external. What it means? It means that externally or from the external source, the flux which is sinusoidal in nature, it is linking this particular coil. Are yes or no? This phi external is linking this particular coil. It means that EMF is going to be induced. It is for sure. EMF is going to be induced in this coil. But what will be its polarity? It is given by the Lange law. So effect opposes its cause. So since because of this flux, the EMF is inducing, so this EMF, what it will do? It will produce its own flux such that those flux is going to oppose the phi external. तो ये जिसके वजह से EMF बन रहा था, वो अपोज करेगा ओरिजिनल फ्लक्स को, क्योंकि उस ओरिजिनल फ्लक्स की वजह से EMF बना. ठीक है. नाउ द as I told you, the flux is going to be occur only if or produce only if when the current is going to be produced in the circuit. So कोई external current होगा, alternating current होगा, because of that the flux you are going to have like this. But to have an induced over here, let me change the color. What should be the direction of the flux? It has to be opposite. देखो phi external ऊपर से नीचे आ रहा है, तो अपोज कैसे होगा? जब अपोजिट डायरेक्शन में जाएगा मीन्स फ्रॉम लाइक इट इज फ्रॉम डाउनवर्ड टू अपवर्ड, तो दिस इज गोइंग टू बी द फ्लक्स डायरेक्शन. ओके, कहाँ गया? So this is phi induced. Ajay, any doubt? Phi induced. Phi induced. है ना? See, oppose. So what should be the direction of the induced current because of which this phi is in upward direction? तो वो डायरेक्शन क्या होगा इंड्यूस करंट का विच इज फ्लोइंग इन दिस पर्टिकुलर सर्किट टू गिव द फ्लक्स डायरेक्शन लाइक दिस. सो विच लॉ वी विल गोइंग टू यूज? फ्लेमिंग राइट हैंड palm rule. Which rule we will going to use? Fleming right hand palm rule. So what it tells? Point your thumb in the direction of magnetic flux. So see, then your forefinger will curl in such a direction that it will going to give you flux in this direction. तो ये फोर फिंगर उस डायरेक्शन में कर्ल होगा जहां पे करंट आपका बनेगा, जिसके वजह से फ्लक्स आपका इस डायरेक्शन में बन जाए. Am I clear? So the current which is going to be flowing in this particular coil, तो वो ऐसे होगा. See, from the left to right it is from front side, and from back side it is right to left. So from front side, कहाँ गया? Yeah, this is front side. It is from left to right, like this, like this, like this, like this, and after this from back side it is right to left. Am I clear? Am I clear? Then how to find its polarity? So what I will do, I will going to assume one fictitious resistance. So here, like at a node, wherever you are finding the polarity, just assume the fictitious resistance. So let me assume the fictitious resistance like this. So this is my fictitious resistance. Now suppose in this resistance a current I is flowing. Current I is flowing. Then what is the polarity of A and what is the polarity of B? So A, it will going to have plus, and B, it will going to have minus. Whenever a current is entering into a resistance, then the first point will be plus, and whenever like wherever it is leaving, it will be negative. तो यहाँ पे देखो, here it is going to entering here ना, so it will be plus. So other will be minus. So here the EMF is E. Any doubt? Is it clear? So what is net EMF in this case? What is this EMF? This EMF is, let me take n turns of a coil into net flux. What is the net flux? Let me take for this flux direction as positive, so phi external minus phi induced. Okay, समझ में आ गया? Any doubt? Or in a simple manner, this Lenz law, this Lenz law is nothing but E equal to minus n d phi by dt. So what is this negative sign? negative sign is opposition to a change, Okay, so this is what your Lange law, and we discussed with the one example that how we can find the EMF. Okay, so let me take another example. Okay, just a second. Let me take another example. Example 2. Okay, so please wait. Meanwhile, let me draw the diagram over here. Okay, so let me make a coil. This is P and this is Q. And this is the direction of phi external. So from the external source, this EMF is inducing. Ajay, is it clear? Ajay, is it clear? So give me the polarity of P, whether it is positive, whether it will going to be positive or negative. Whether it will going to be positive or negative. Okay, so see here, since this, let us assume that this phi external is sinusoidal in nature. So since this flux is linking this coil, therefore EMF is going to be induced. So this is your EMF. Okay? But what will be its polarity? It is given by the Lange law. So if you see here, flux externally is in from left to right direction, then the phi induced, it has to be in this direction. Then only we can say na it is opposing the external flux. So this is phi induced. This is phi. Sir, EMF फ्लक्स के इंक्रीज करने से इंक्रीज करता है कि रेट ऑफ चेंज ऑफ फ्लक्स के इंक्रीज होने से इंक्रीज होता है. It is a good question, but again a basic question, because if you see the formula here, Ajay, if you see the formula, by increasing the rate of change of magnetic flux, the EMF is going to be increasing, not by increasing the flux. ठीक है, with respect to time, it has to increase, then only the EMF is going to be induced. ठीक है, जो आपने लिखा है ना EMF increase, so here I am assuming that it is independent of the time, है ना. और यहाँ definition में with the rate of like with the increment in the time, whatever time that you have taken, with the time as passes, the flux has to be increased such that EMF is going to be increased. ठीक है अजय, चलो कहाँ गया, yeah. So what is P? P is positive or negative? So see, so what should be the current direction in, like the induced current direction in this particular coil, such that it will give you phi I in this direction, Fleming right hand palm rule. So point your thumb in the direction of phi induced, then this forefinger will curve in the direction of induced current. So from front side it is upward, from downside it is downward. Okay, means from back side it is downward. So it means that from let me change the color. So from front side it is upward, है ना? So this is front side, upward. And from back side it is downward. Then what I told you, assume the fictitious resistance. So assume the fictitious resistance like this. ठीक है? So this I which is induced current, is going to flow through this resistor. So definitely it will going to enter at this point, so it will be plus, and here it will leave, so it will be minus here. So P will be positive and Q will be negative. Done? So let me discuss the last example in this by taking the transformer. Okay. So please wait, and if you are having any query, Ajay, please do let me know. So suppose this is your transformer. Okay, this is your transformer, and we know that a transformer will have both primary and secondary winding. So let me make the winding here. So this is your primary winding where the source is going to be connected. A primary winding is a winding where the source is connected. So this is okay. थोड़ी देर में इसको लिखेंगे. What is the voltage basically? Let me make the secondary. Okay, so this is V of t, which is Vm sin omega t, and this is your load. Ajay, any more doubt? This is your load. Let me take the number of turns at the primary side as N1, and at secondary side let me take N2. Okay. Now see here, this is the primary source of a voltage where the current is going to be flow. So let me take the primary current as I1. Now since the voltage is sinusoidal in nature, therefore the current that it will have is also going to be sinusoidal in nature. Here I have ignored the harmonic part. Okay? So the current is going to be sinusoidal. So because of this current, a EMF is going to be induced, sorry, the flux is going to be flow because this current is flowing through this particular coil. तो देखो current इस तरीके से जा रहा है. So therefore it will going to give you the magnetic flux. So flux direction will be upward. The flux direction will be upward. Why, sir? Why the flux will flow in this particular limb? Because this is your iron. Because this is your iron. And I told you the magnetic flux is always try to flow, take the low reluctance path, and this iron is going to provide you low reluctance, just like your resistance and the current relation. A current is always try to flow through low resistance path. तो ये direction हो गया उसका. Similarly, here also it will flow like this. Similarly here. Similarly here. Okay, so this is the direction of your magnetic flux. Sorry, just a second. Okay, so this is your phi. This is your phi external. This is your phi external. Phi external. Phi external. Okay, so where is your coil? Coil you are going to have at the primary and the secondary. So definitely EMF is going to be induced over here. Yes or no? Now, according to the Faraday's laws, the EMF is going to be induced, but what is the polarity which is given by the Lenz laws? So, since here flux direction, external flux direction is upward, then what should be the direction of induced flux? It should be downward. तभी तो हम बोलेंगे ना opposition. तो देखो यहाँ पे it will be downward. So, just a second. Here it will be downward like this. ठीक है? So this is your phi induced. Phi induced. What about here? यहाँ पे phi external is downward. It means that phi induced, it has to be upward, such that it becomes opposition. Phi, sorry, phi induced. Great, excellent. Now my next task is to assume the fictitious resistance on both sides. So let me take the fictitious resistance here. Okay. I hope this color is visible to you. This is your fictitious resistance. Done. Now see, please do not see. Please do not see phi I here, like I1 here, because this is from source current. Okay, this is from the source side. But this phi induced is because of induced current. then what is the direction of the induced current which is flowing here? So see, phi induced is downward, therefore your current or the induced current direction should be from front side, it will from right to left. So from front side it will be from right to left. So like this. Then after that, this current is going to be enter here. So this part will be plus, this is fictitious resistance, na? This part will be plus and this part will be minus. So can I say, my friend, this particular point will be plus, this particular node point will be plus and other will be negative, है ना? आप इसको A और B बोल दो, A और B, और वहाँ यहाँ P and Q बोल दो इसको. So A will be positive and B will be negative. Okay. So let me rub this. Okay, just a second. So this is induced current. This is I. That is induced current. Let me write II. So induced current. Okay. So we have got the EMF E1. Let me write the EMF E1 here. And what is the value of E1? E1 is number of turns of this coil N1 and d phi by dt. What is the flux flowing through this coil? One flux is phi external and another flux is phi I. So the net flux is phi external minus phi I. So this is your E1 value. Okay, just a second. So this is your E1 value. Now come to E2. देखो, so phi external is downward, so therefore phi induced has to be upward. Then EMF will be what? E2. Let me write here. E2 will be what? Since EMF is inducing in this coil, so take the number of turns as N2, into d phi by dt. So what is the net flux in that? Phi external minus phi I. Please do not think that this phi I and this phi I are same. This phi I depends on the load. This phi I depends on the load. ठीक है? चलो, let me inbox this. Okay. चलो तो पहले फ्लक्स की द EMF की डायरेक्शन फाइंड कर लेते हैं. सो फ्लेमिंग राइट हैंड palm rule, phi induced is upward, so therefore the current direction is from front side it is from left to right and from back side it is right to left. So from front side it is left to right from front side like this. So here assume the fictitious resistance. So if you see, this becomes positive and this becomes negative. This becomes positive. Let me change the color. I think it is not visible. Just a second. So it will be positive and it will be negative like this. Am I clear? So EMF here will be E2. So EMF here will be E2, and let me take that current is I2. So this I2 current is nothing but your induced current, which is nothing but your load current in this case. Is your load current in this case. Am I clear? Any doubt in this? Am I clear? ठीक है? Now some of you are thinking that, sir, during the Lenz law you have written minus n d phi by dt, but here you have missed negative sign. No, I have not missed. Why, sir? Because that negative sign is what? Opposition, na? That I have already found it here because circuit is already given to me. So जब भी circuit दिया हुआ रहेगा, then we can directly find its polarity. So here this polarity is plus and this is negative. So since we have already obtained the polarity, then in this case we need not have to put negative sign. Then the question arises, then sir, when to take negative sign? Please mark my word, whenever circuit is not given, we will take negative sign here. But if circuit is given, then by default we can easily find its direction, then its polarity. Then in such cases we need not have to use negative sign, because that negative sign we had already taken into the while finding the polarity. ठीक है? So this is all about the Lenz law. So this is a question. Take this as a homework question. This is a homework question. Okay. The core of a single phase 2-winding transformer is subjected to a magnetic flux variation as shown in the figure. So this is a transformer where flux is flowing in this direction in the core. N1 turns is 100, N2 turns is 200. Then what will be the EMF EAB and EMF at secondary side ECD when you are having the flux like this, a triangular wave? ठीक है? So peak is 0.12 and time period is 2 seconds. So we need to find the EMF EAB and ECD. So this is option A, option B, option C and option D. So please do solve it. Let me move aside one more time and take a screenshot of it. On a count of 5, 1, 2, 3, 4, 5. Okay. So please do solve it, because the concept we are already discussed in the last example. So please do solve it, and whatever answer or the option you are getting, please do post in the comment box. In my free time I will going to check all the options whoever posted in the comment box. Okay. All right. So any doubt? Any doubt till here? Ajay, Vicky M. Any doubt? Okay. So my dear friend, please do join our Telegram group. It is very important for you, because there we are posting the daily quizzes and the anyway, as you know that the PDF of the session is going to be you will going to be found in the Telegram group, because whatever session we are conducting over the YouTube, the PDF of the same is shared over the Telegram channel of the IMS Gate Academy. Okay. So once this session is going to be over, please do watch the lecture once again, and whatever your doubt after that, if you are having, then you can comment in the comment box. In my free time I will going to I will go through all the doubts. So guys, if you have enjoyed the session, so please do please do hit the like button. It is very important for us, and please do share the session link with your friends, so that they also benefited or they also going to get the benefited from this particular session. And if you have not yet subscribed to our YouTube channel, please do subscribe. It is important for you, because not only such kind of initiative like the general videos wherever we had discussed about the post gate guidance, the gate booster, and so on. So like we are in the near future, we are coming up with more new initiative. So for that, you should be subscribe to our YouTube channel, and if you want to be the first one to get notified for our all the session, then please do press the bell icon as well. So see you next time, which is on tomorrow. So the timing will be same, and we will going to discuss the new topic, which is again going to be very important for you. So bye bye, and take a very good care of your health.